Hello again. This little video is about DHCP running off a router. We're going to set up DHCP on router 2 and it will provide an address to this PC down the left here. Now we can provide a DHCP to VLAN 33 devices down here, VLAN 22. The switches can obtain DHCP, this PC out here, that server out there, can all run off a single router, just multiple pools or multiple scopes. Not huge amounts of value putting DHCP onto a router, but it's nice to know that we can do it if need be. The actual value is on the interfaces, where we're going to run a helper address. So let's have a look at what actually happens with DHCP and then configure it so that it actually works. So we'll just go into simulation mode here, and we'll just go onto this PC, go onto its IP, so it's static configure at the moment. Just quietly, before you set this up, if you put a static address out there and ping from that machine up to router 2 and show that it works, then that's a good idea, and I've already done that, so I know that it works. Okay, so I've just clicked on DHCP there to request an address, and let's have a look at our packet. So DHCP runs at layer 7. We're using a source port of 68 in UDP, destination port of 67, and all we're doing is broadcasting out. The destination IP here is 255.255.255.255, so we're sending out a broadcast across VLAN 22 or our network, and we're trying to find a DHCP server. What's going to happen is we don't have a DHCP server running on this network at the moment. This server here, while it can support DHCP, at the moment it's off. So I don't want to run it on that. I actually want to run DHCP off router 2. Now, router 1, or a router's job, is to block broadcasts from extending beyond the border. So this broadcast is going to hit this router on the sub interface for VLAN 22, and we need to put something into that sub interface to say send that request on to the actual DHCP server. Now the same for router 3. If we were to put DHCP onto this system, so that PC there, that's actual physical interface, not a sub interface, gigabit 00, and we'll need to put something on that if we're going to get a DHCP system happening, and it'll forward on to wherever our DHCP server is. So router 2 is a pretty daft place to put it. There seems to be a lot of traffic going through router 2. It's our internet connection, so normally you wouldn't, but we've got to put it somewhere, so I thought, why not there? Okay, so let's just capture forward, look at our broadcast go out. It goes across our network, goes everywhere, and dies across the board because we do not have a DHCP server running. So we'll put on the helper address to start, and then just see what happens from there. So on router 1, now I already know that our VLAN 22 is sitting there, so 192.168.10.1 is the address. So the network number is 192.168.10.0, and I've got a habit of not doing those correctly, but anyway, let's go in. So conft, so the interface gigabit 0/0.22, if you remember sub interfaces, and we're going to put in the IP helper address. Now the helper address is the IP address of this router. So let's have a look at what addresses are on router 2. I should have prepped this before I started, but anyway. So Cisco, enable, class. So if you show IP interface brief on router 2, we've got 4 addresses. Interestingly enough, we can put a 5th in there. We can have a loopback address. As long as it's propagated across our network, we should be fine. We would do that because a loopback will not turn off. We can unplug all these cables, or at least one or two of them. As soon as we unplug gigabit 00, then we will not have that address available anymore. So our routing protocol will fail on our networks. So putting a loop back in, the interface will always be up, and should our routing system fail or connections go down, we'll still be able to access that router via the loopback address. But in our case, we're just going to use this one. How about that? 10.0.0.1. That's a nice easy one to type in. So let's go back onto router 1 again. So what we're saying is, if we do get a DHCP request on this interface, a broadcast, then this IP helper address is going to send that request on to this IP address. So it's turning that from a broadcast into a unicast. So let's have a look at what the outcome of that is. So let's go back into simulation mode. We'll go back to our PC and we'll set up DHCP again, and let's step it forward. So we're receiving the broadcast, and now we've forwarded onto router 2, and it should die there because we're actually not running DHCP at the moment, but that IP helper address is what we want to run on that interface. So it's the interface that receives the broadcast that needs the IP helper address added to it. So let's just pop onto router 3 here, and let's just go. So our interface here is gigabit 00, it's the actual physical interface, and IP helper address, and we'll use the same IP for that router at the top. Doesn't have to be, it could be any of these IPs on router 2. So 192.168.30, 200.20.21, 10.0.0.6, 10.0.0.1. This router will accept all requests for DHCP from any of those interface addresses. So we've got an address there, IP helper address. Let's just turn this guy onto DHCP, and it'll sit and request as well. So that will fail, that will fail. So pretty much these IPs underneath there are redundant. So we'll see and configure this all up, see how it goes. So one thing you might notice is this is a different network out here. So 192.168.10.64. Oh, hang on. 192.168.20 network. It's a big fail, isn't it? I haven't changed that back. Should be 20 network. And we'll see how it pops anyway. All good. There you go. Interesting, I wonder why I never changed that. Okay, so let's hop in and create our scopes and everything else that we need to do on router 2. Okay. Nice. So configure terminal, and what we're going to do, we'll create the scope for this network first. So IP DHCP, and what we're going to do is first up exclude addresses. And what it says is, or the way this DHCP runs is, we're going to exclude a range of addresses from our scope, and then we go in and create our pool. So we put a range in, so 192.168.10.1 is the first address in the range, and then 192.168.10.10 could be the last address. So we're excluding from the pool addresses 1 to 10. And that's it for the scope. So IP DHCP pool now is going to be created, and we need to give it a particular name. So VLAN for admin might be a good one. So admin pool might be a good one, or even router 1. So give it a destination so they actually know what the pool is. Makes sense. So we're in the pool, we need to configure it, Let's just put a question mark in there. Now this is a lot less than physical routers, but it's enough for us, so we can give ourselves our default router, which is going to be the IP address of that sub interface, DNS server if we've got one running, and a network command. There is an option down there, which is all the raw ones, which generally we don't play with, but they come in very handy if you need to put something across your network. So let's have a look. So the network that we're actually on is 192.168.10.0, and we need to put in the network mask as well. So 255.255.255.192. Remember, this is a /26 network out here. So for this VLAN 22, 192.168.10.0/26, that's our network that we're actually playing with. And we need that because when this interface receives the address and forwards it, part of this DHCP server needs to know which interface received the request to apply the correct pool. So the only thing that can tell it is actually the interface that receives the request. So the IP helper address does more than just forward it on. It actually says which network we're actually coming from as well. So let's put in our default router. Unrecognized, default, incomplete, love it. Okay, so what is our gateway for our network down here? What is the IP address of the sub-interface gigabit 00.22? So 192.168.10.1 was our default router. If we want to put a DNS server in, then whatever it is, 192.168.20.10, we'll make the server out on the right here, that one a DNS server for our network. So that should be it. So let's have a look. Show run on router 2, and we've got our IP DHCP excluded addresses. So 192.168.10.1 to 192.168.10.10. We've created the pool called admin pool. We've said this is the network that is going to exist inside this VLAN 22 there. Our default router, our gateway address is 10.1, and the DNS server we're using is just going to be a DNS server that's floating in the breeze somewhere. So let's go back and see if it actually works. And it has given us a 10.12 actually. No default gateway, no DNS server, so let's redo and see if it actually does it correctly, which is good. So that's worked. 192.168.10.12, correct subnet mask, correct gateway. 192.168.20.10 is our DNS server. So let's just double check that things are working. So let's ping 10.1. So our gateway's working, our IP's working. We should set up a DNS server just quickly. Let's do a really basic one. We'll turn it on. Bob. There's an A record, and that A record can be 10.0.0.1. Let's add that. So that's running, hopefully. Let's just make sure that we're actually 192.168.20.10. So that's good. So that DNS is running. So let's see if we can ping Bob. See if DNS is working. It may not. You never know with packet tracing. It does seem to be taking forever. Yeah, finally. Cool. So DNS is working. Our configuration, everything is correct. So pretty simple actually. Let's put the scope on for here. So 192.168.20.0/24 is our network. This address is going to be changed. We've got our IP helper address already on our interface there. So let's go through the process of creating a scope again. So IP DHCP excluded address 192.168.20.1, and let's exclude everything up to 30. 192.168.20.30. We could also, if we wanted to, just exclude a particular address, so 254 for some reason we might like that, just a single address. That won't come out in our scope. So IP DHCP pool, and let's call this router 3 LAN as our scope. Our network is going to be 192.168.20.0. Our pure C class. Our default router 192.168.20.1, and our DNS server 192.168.20.10. It can be the DNS server internally as well. Now while I'm in here, if you look at it, there are these options. So go onto a website and look for DHCP options. They run from 0 to 154. An interesting one for us is 128. And that is to set up a TFTP server. So option 128 is for TFTP, and then we'll put the service in, so let's just chuck it on the same server. Okay, well then 150, I think 150 might be a TFTP as well actually. Both are, 128 and 150. So Packet Tracer doesn't support all the options, but if you want to use the 250 odd different options, so 0 to 254, then go for it. Now that's an option, that's an option, that's an option, and then you've got the raw options. So they're all options that actually exist in there. Okay, let's have a look at our running config now. So we've got excluded addresses, different networks, so those two are bound together, and our DHCP pool for router 3 LAN comes up with this address range. So let's just have a look at this guy. He's already acquired it, but let's go through the process again. DHCP, and 192.168.20.31 is acquired, correct subnet mask, correct gateway, correct DNS server. So we should be able to ping other stuff from here. So 192.168.10.1, and we get a reply. So good. That pretty much is DHCP off a router. Pretty clean and simple. So don't forget your IP helper addresses. Won't go to that one. Won't go to that one. So IP helper addresses on the interface that receives the request. On this network down here with router on a stick, I put it on the sub interface, not the parent. On this network where we're actually connected directly straight in and configured everything correctly, then worked quite well just on the actual interface. So this one was gigabit 00, this one was gigabit 0.22 for VLAN 22. And our router happens to be, or router 2 happens to be the actual DHCP server. So, all good. Thank you for that. Enjoy.